Hello, today I'll be talking about this poster, which is highlighting my thesis, which is research in the field of soccer. The research is titled Clustering Attacking Positions to Value Different Play Styles for Soccer. What I'm doing is basically I'm looking at possessions and specifically passing chain and seeing if I can identify what type of passing chain it is from the data provided. So essentially I'm creating a framework to identify the type of attack. In soccer, there are a huge variety of strategies that can be included as your attacking plan, from counter-attacking to the long ball to a slow possession base. And this basically attempts to create a framework that identifies this in a simple and easy way that can then be utilized later to then create sort of more research or create better understandings of teams and league performances. So the first thing was to get the data, and this was public data from StatsBomb that highlighted the events in a game. Using this event data, I created passing chains. So each row represented a single passing chain and highlighted the details of that possession. This describes the duration of the possession, the start location, the ending location, the details of the passes, so how long they were, what angle they were usually at, what direction, the type of passes, to be from crosses to short, quick passes. Then also looked at the pattern of play it was in, and also the positions of the players beginning and ending the passing chain, followed by the end result of the chain. So was it ended with a turnover? Was it ended with a shot on target, et cetera, et cetera. To create this framework, I used something called model-based clustering. So to break that down, I wanted to identify a probabilistic approach to identify these passing chains. The way I did that was I used soft-based clustering, which essentially assigns each row or each, in this case, possession, a probability of being within each cluster. A cluster over here represents a type of attack or a play style. So a cluster could represent a counterattack, a cluster could represent a long ball or a possession based. The model-based clustering is ideal for this because it generates probabilities from it being a soft-based clustering, but also it selects the optimal number of clusters. So it will look at the data and identify how many unique types of play styles there are for that specific league. When I say that specific league is because we ran these clusters independently of each league. So we would have 7 clustering algorithms, but they were the same algorithm, just fed different data. And the data was basically each league's data. The reason we use this all separately, not together at once, because leagues have different implications. The Premier League versus the La Liga can have different sort of features because the Premier League or the teams in the Premier League have more games that are playing outside the Premier League in terms of the FA Cup or the Carabao Cup and the League Cup. Another feature is also we have women's data and men's data, and there can be certain differences just from a physical point of view that would result in clusters being skewed in one way if we were all put together. Hence, we used all leagues differently, but they all provided the same results in the sense that they all provided 9 clusters, implying that there are 9 different play styles. The results are basically sort of the identification and showing that there are different unique play styles that this framework can identify. And the applications of this framework are immense. If we look at the graphs on the top right of this poster, this is just one example that looks at the passes in the box for each cluster across all the leagues and competitions. So there's a clear fluctuation in seeing which clusters or which play styles work better for different leagues and competitions. Moreover, another key aspect of this is we can look at the differences in leagues and how play styles are different play styles work in different leagues in a better way. Moreover, the scales on the vertical axis can help us understand different metrics and how they are different across leagues. For example, the Premier League versus La Liga, you see more passes in the box for La Liga. This implies that they're either more attacking based or the Premier League is a more defensive heavy and maybe more sort of harsh or rough play is allowed from center backs. So the applications are immense. Something that I want to do in the future with this is create a long short-term memory model which would predict the passing chain based off the previous passing chains. This provides immense value for a team if they want to sort of predict what will happen against them from an opponent based off how they've been playing the first 15 minutes of the game to predict the next 15 minutes of the game. And this is by no means a finished product. There's a lot of things that can be worked on. Better descriptive data can help identify clusters and create these differences more unique, and also accentuate how good this framework is. So there are a lot of features that can be further amplified. And with that, I am excited to see what the future holds with this research. Thank you.